I've already been introduced. Sorry about the English, but I'm slightly better at English than I am at Norwegian. 20 years ago, 21 years ago when I started this, I wasn't the pioneer of this research, but we didn't call it ocean acidification. It was only when the biologists came in and they saw that this pH change that we were looking for the pH change which would signify how the ocean was providing a great service to us by actually removing CO2 from the atmosphere and therefore lowering the potential for greenhouse warming. You can see a paper we had 2 years ago now. This is the ocean depth, and this is Antarctica through the tropics up past Iceland into the Nordic Sea. Oops. This is the amount of carbon in excess from the pre-industrial revolution, so the change that has happened since 1870. And you can see that it's in our region. I'm going to talk about ocean acidification and its effect on fisheries and ecosystems by the end. And this is the only part of the globe presently where the whole water column has been affected. The pH has dropped, the carbon has increased. So we're already touching the benthic, the sediment-dwelling organisms. Now, just a small, short definition, confusion. Ocean acidification is a lowering of the pH. It's towards an acidic state. It doesn't mean the oceans will become acidic. There's not enough CO2 in the fossil reserves to go below 7. However, we're getting pretty close. This is the mean global pH, ocean pH, prior to the Industrial Revolution. We're already here, and by the end of the century, this is time, sorry, by the end of the century, we'll have a hydrogen ion concentration which is about 2.5, 3 times what it was in the glacial interglacial times. It's seems like a small number when it's pH, but if I told you there was 3 times as much cadmium or something, and the tolerance level we'd gone past the tolerance level by 1950, you can see the danger, the challenge. I'm not saying the danger, it's not a danger for all ecosystems, but the change in all ecosystems. Just a little overview of what we do at the Bjerknes Center. We do observations. We observe in the Southern Ocean, the Arctic, the Indian Ocean, very strong in the Nordic Seas and the Barents Sea, relevant to the fisheries that I'm going to talk about. We do a lot of experimentation on ecosystems and organisms. This was last summer in New Orleans, the largest, longest, most northerly CO2 perturbation experiment. And then we take this information and then we model scenarios of Arctic change, global changes, but also we can take it down to the scale of a fish farm, we can take it down to the scale of a fjord. So we go through many, many different levels. A good example of this is that paper in the Norwegian the Norwegian Arctic Climate Impact Assessment this year, showing that in our region, very big changes in pH by the end of this century, bigger than the global average, in these regions of the high Arctic or our high Arctic. But don't be too complacent. These are also bigger than most of the global changes in pH along our coast. I always talk about sex and people will remember it. This is sea urchin reproduction. This is what happens if you grow sea urchins under a CO2 scenario relevant to late this century. And you'll see that it hits at every single level. It's fertilization. It's the efficiency of sperm motility. If that is successful, you get reductions in embryo development. And these are all significant, 10, 20% at this point, and then further 20%, 25% of larval development. Therefore, all of us that like eating at Cornelius, for example, they're going to have to go much further afield to find their sea urchins to feed us with. And this is just one very short example. We can go through lobsters, we can go through most calcifying organisms through to coral reefs will do generally very badly under high CO2 concentrations. A good example of this, this is the US coastal shellfish industry, fisheries industry, a catch value of $4 billion, and it's only the blue parts which are completely unaffected by ocean acidification from all the experiments that have been done globally. Taking it even further and more locally, this is a paper recently in press in the ICES journal, is that we see climate change will generally be good. Well, they think it will be generally good for the high latitude fisheries like the Barents Sea. So the black is with no biogeochemistry, no pH change. If you do the model, the Barents Sea will be 70% higher than it is today. I'm not saying this is a scenario, it's not a prediction. And all the way through, we do very well. But you bring in acidification, you show how the benthos and how the plankton may change, and you can halve that. These are very, very large numbers. And then when you go further south, these smaller fisheries, well, different fisheries, dependent on different species, different sensitivities, have actually become negative. They're going to lose value over this century. And then finally, to really put it into perspective, it's relevant, there's some tourist representation here, it's relevant to this welfare associated with the existence of diverse natural ecosystems. This is global coral reefs. We have the coral reefs off Rust, or in fact all the way up the Norwegian coast. People go to Lofoten because they like the pristine environment. But these corals they will be under stress quite soon, this century. But look at the numbers. These are the annual economic damage of ocean acidification-induced coral reef area loss in billions of dollars every year, 800. So this is, we're talking big money, big cost, potential cost from this. And I won't go into this. It will last for 100,000 years. Everything that we do, the perturbation, a part of that perturbation will last for 100,000 years. And I have to stop now, I'm afraid. One slide too many. But we can provide your scenarios relevant to your industry. Thank you.